So what if you're asked to find a formula for a sequence? Well, you first want to look and see what's happening between the terms. I'm looking at this and I'm saying, well, they just added 3. That's pretty straightforward. Okay, whenever I see that there's adding and subtracting between the terms, then it's fairly easy to create a formula for it. It's basically kind of like a slope. If you think of the n as the x value, which it is, those are my x values, and I'm going, my y values are going up by 3. So really this is a linear function, and this is the domain, and of course this is the range. So it's kind of like that. 3 is the slope in a sense. So what we're going to do is we're going to go ahead and say, okay, I've got 3 times n. All right, that's 3 times the input. But here's the problem. If I just put in a 1, that times, I put in a 1 for this first one, put a 1 there, that's just going to give me 3. And I need it to be a 14. And so what I do is I say, okay, what would I add or subtract to get my 14? Well, if I put in a 1, I'm going to have 3, and I would need to add an 11. So perhaps that's the formula. So here's what I do. I say, okay, plus 11. So 3n plus 11. It wasn't minus this time, it was plus. Let me try another one. If I put a 2 in, okay, does this give me what I'm supposed to have? Well, I'm supposed to have a 17. Let's see. That's a 6 plus 11. That works out. Okay, so I think, hey, I've got the formula. It's 3n plus 11. Let's try it one more time, making n a 3. So I have 9 plus 11, there it is, 20, and it works. So my formula is 3n plus 11. Remember, when you have a constant number being added or subtracted, you put that in front of the n, and then you're going to need to adjust if it doesn't produce the value that you're supposed to have. So let's take a look at another one. Okay, we have the numbers 2, 4, 6, 8, and it's easy to tell what's happening here. We have a 2 being added each time. So this is the same kind of idea as that we had before. So I'm going to place a 2 right in front of n. This one's different, however. When I put a 1 in for n, in other words, this is the term number, and it should produce the 2, or some adjustment of it should produce a 2. So there's these. If I put a 1 in for n, will it spit out the 2 like it's supposed to? Well, yes, it does. So in this particular case, I don't need any adjustment at all. So let's just double check. If I put a 2 in, will it give me what it's supposed to give me, which is a 4? Yes. Okay, so my formula, my general formula would be 2n. There's that one. Now let's take a look at one that looks a lot harder. It's really not that bad. If you watched the previous videos, you know that if we have an alternating sign, it's very simple to create the formula for that. So what I'm going to do is just, first of all, I'm going to make sure that I have a -1, okay, and then I need the power to be either n plus 1 or n minus 1. And I think this time I made this one n plus 1. So let's just see what that would do. If I put in a 1, then that would be -1 to the 1 plus 1 power, which is to the second power, which is a +1. And that does give me the positive that I need to start with here. Okay? When I put in the 2, it's going to be to the third power, so it'll give me the switching to the negative. So there's the top 1, right? That's the top 1. I'm going to go ahead and put that over on a 1 as the denominator to see how I can get started with this. Oops. So we need a 1 to become a 2, to become a 3, to become a 4, to become an 8. So I'm going to go ahead and start with this denominator, and I'm going to look at what's happening between each of the numbers. Well, it looks like it's being multiplied by 2 times 2 times 2. So that's what we want to look at. You want to many times look at the numerator and denominator separately. Numerator and denominator separately. We think we have the numerator, so let's take a look at how we could get the denominator. If I just put a 1 to the nth power, well, then that would give me a 1. That would be okay. But then on the second one, 1 squared is not going to give me a 2. But I do notice this. I do notice that this is 2 to the first power. I notice this is 2 to the second power. And I notice this is 2 to the third power. Well, what would be 2 to the 0 power? Lo and behold, it really is 1. It is the first one, which is a 1. So it looks like that they're taking a 2 and raising it to not n. Okay, notice this one. If I put in a 1, the power is 1 less than. If I put in a 2, the power is 1 less than. Put in a 3, the power. So it looks like they're saying n minus 1 because the power is 1 less than the position. I'll say that again. The power is 1 less than the position. These are the positions, 1, 2, 3, 4, first, second, third, fourth. So let's take a look at our rule that we think we have established, and let's see if it works. I'm going to check, I'm just going to check this one right here. If I make n 3, okay, let's take a look. Negative 1, 3 plus 1 over 2 to the 3 minus 1. Well, that's going to give me, move over here, that's going to give me negative 1 to the fourth power, which is going to be a positive 1. So we know that this term will be positive. That's a good thing. We see a positive 1/4. The list is going to be a 2. That's 2 squared, that's 4, and it checks. Okay, I could check a couple of others, but I'm going to go ahead and move on to the next one. If I have another one, I don't have another one. Well, excellent. All right, made it under 7 minutes. Thanks for watching.